Welcome to Vedavyasa Academy. Dear students, in this session we discuss vector differentiation. In vector differentiation, you see what is before going to discuss vector differentiation, what is vector function? We discuss vector function. So here vector function, let S be the set of real numbers. S be the set of real numbers corresponding to each scalar t belongs to S. S be the set of real numbers corresponding to each scalar t belongs to S. Let there be associated a unit vector F bar. Let there be a associated a unique vector F bar. Then F bar is said to be vector function. Then F bar is said to be vector function or vector valued function. And S is called domain of F. This S is called domain of F bar. We write F bar equal to F bar of t. We write F bar equal to F bar of t. Let I bar, J bar, K bar be three mutually perpendicular unit vectors. I bar, J bar, K bar. We know that. So I bar, J bar, K bar be three mutually perpendicular unit vectors in three-dimensional space. We can write F bar equal to F bar of t equal to F1 of t I bar plus F2 of t J bar plus F3 of t K bar, where F1 of t, F2 of t, F3 of t are real valued functions which are called components of F bar of t or F bar. Here F1 of t, F2 of t, F3 of t are real valued functions which are called components of F bar of t or F bar, where I, J, K are constant unit vectors. We know that. Okay, this is the definition of the vector function. What is vector function? Once again you see, let S be the set of real numbers corresponding to each scalar t belongs to S. Let there be associated a unit vector F bar. Then F bar is said to be vector function or vector valued function. S bar is called domain of F bar. We write F bar equal to F bar of t. Let I bar, J bar, K bar be three mutually perpendicular unit vectors in three-dimensional space. We can write F bar equal to F bar of t equal to F1 of t I bar plus F2 of t J bar plus F3 of t K bar, where F1 of t, F2 of t, F3 of t are real valued functions which are also called as components of F bar of t or F bar, where I bar, J bar, K bar are constant unit vectors. This is the definition of the vector function. How to find derivative of vector function? You see, all of you, here derivative of vector function we discuss here. Let F bar be a vector function on an interval I, where a belongs to I. Then limit t tends to a, F bar of t minus F bar of a by t minus a, if it is exists this limit exists is called derivative of f bar at a, is called derivative of f bar at a and denoted by f bar dash of a or df bar by dt at t equal to a. We say f bar is differentiable at t equal to a if f bar dash of a exists. Okay, all of you. The derivative of a vector function is limit t tends to a f bar of t minus f bar of a by t minus a if it is exists. We say derivative of f bar at a can be written as f bar dash of a or df bar by dt at t equal to a. This is the derivative of vector function. Okay, all of you. Define higher order derivative. Derivative of a vector function is completed, and now we define the higher order derivative. So, what is derivative of vector function? Once again, f bar be differentiable on an interval I. Then f bar dash equal to df by dt be derivative of f bar. Then we define second derivative or higher order derivative of f f the f bar dash limit t tends to a f bar dash of t minus f bar dash of a by t minus a exists for every a belongs to I1. This is another interval I1. I1 is subset to I. I1 is subset to I. Then f bar dash is said to be differentiable on I1. It is denoted by f bar double dash of a or d square f bar by dt square. Similarly, we define f triple dash of t, etc. Okay, so we define like that higher order derivatives. Okay, now higher order derivative of vector function. Here some properties of differentiable vector functions or functions. Some properties of differentiable vector functions or functions. So first one, derivative of a constant vector is 0. Derivative of a constant vector is 0. This is first important result or first property. Here, if a bar and b bar are two differential vector functions, or two differential vector functions, okay, then d by dt of a plus or minus b equal to dA bar by dt plus or minus dB bar by dt. This is the first result. And the second result, third result. Here in vectors, two types of products is there. Dot product and cross product. We know that. For dot product, we represent a vector dot b vector. So derivative of d by dt of a vector dot b vector equal to dA bar by dt dot b bar plus a bar dot db bar by dt. Okay, so here cross product d by dt of a vector cross b vector equal to dA vector by dt cross b vector plus a vector cross db vector by dt. This is the fourth result. So in this one, now fifth property. What is fifth property? Here, fifth property is if f bar is a differentiable vector function. F bar is a differentiable vector function. Phi is a scalar differentiable function. Phi is a scalar differentiable function. Then d by dt of pi f bar, one is the scalar function and one is the vector function. Then pi into df bar by dt plus d pi by dt dot f bar, pi dot df bar by dt plus d pi by dt into f bar, into this is not dot. Here if f bar equal to f1 of t I bar plus f2 of t j bar plus f3 of t k bar, where f1, f2, f3 are the Cartesian components of the vector function f bar. Then differentiation of this f bar is df bar by dt equal to df1 by dt I bar plus df2 by dt j bar plus df3 by dt k bar. These are the results. Now the seventh one, the necessary and sufficient condition for f bar of t to be constant. F bar of t to be constant, vector function is df bar by dt equal to 0. If the function vector function is constant function, then it is a derivative of that one is 0. Okay, all of you, these are the results or properties of differentiation of the functions. Here we define partial derivative, derivative of the function, partial derivative of the function, derivative of the function, partial derivative of the function. Derivative of the function is completed. So in partial derivative, there are more than one variable. The function defines more than one variable. The function have more than one variable. Partial derivative for vector valued function, if f bar be the function of scalar variables p comma q comma t. Okay, f bar be the function of scalar variables p comma q comma t. Then we write f bar equal to f bar of p comma q comma t, treating t as a variable, treating t as a variable, remaining p comma q are constants. We know that constant of differentiation 0. So t as a variable and p comma q as constant. Then we define limit delta t tends to 0, where delta t is the small amount of the t. F bar of p comma q comma t plus delta t minus f bar of p comma q comma t by delta t. If it exists as a partial derivative of f bar with respect to t, and is denoted by dou f bar by dou t, dou f bar by dou t. So we define similarly dou f bar by dou p, dou f bar by dou q, dou f bar by dou p, comma dou f bar by dou q also. This is the definition of the partial derivative definition. So derivatives, partial derivatives. In derivatives, we complete derive, we complete derivative the variable. In that only one variable is there. So in case of in case of in case of the variables are p comma q comma t. Okay, variables are p comma q comma t. We make partial derivative, means one is the variable, we treat one is the variable, p comma q are constants. Suppose f of x comma y is there, we derivative with respect to x, dou f by dou x is the partial derivative. In case of df by dx is the derivative of the function. Dx by d, this is derivative of the function x is 1, derivative of the function y is dy by dx. We denote here both, we can derivative. In this case, we can derivative only one variable, other variables are constant, other variables derivatives 0 in this partial derivative. Okay, all of you? That's all. Okay, properties of partial derivatives. We discuss here properties of partial derivatives. Here, first one. Here, dou by dou t of pi a bar. Here, pi is the scalar function, a bar is the vector function. Then dou pi by dou t a bar plus pi dou a bar by dou t. This is the one. Means here one is the scalar function and other is the vector function. We can multiply like this. Okay, so if lambda is a constant, then dou by dou t of lambda a bar equal to lambda into dou by dou t a bar. A bar is the vector function, lambda is the only constant. Then we can use this property. If c bar is a constant vector, c bar is a constant vector, then dou by dou t of pi c bar equal to c bar dou pi by dou t, where pi is the constant function, c bar is the constant vector, means there is no variables. Then we can use this property. If a bar comma b bar two functions, vector functions, then dou by dou t of a vector plus or minus b vector equal to dou a vector by dou t plus or minus dou b vector by dou t. This is dou t. Okay, dou t, this is dou t. Dou by dou t of a vector dot b vector equal to a vector comma b vector two vector function, here dot product, then dou a vector by dou t dot b vector plus a vector dot dou b vector by dou t. If a vector cross b vector means cross product, dou by dou t of a vector cross b vector equal to dou a vector by dou t cross b vector plus a vector cross dou b vector by dou t. If f bar equal to f1i bar plus f2j bar plus f3k bar, f1, f2, f3 are the Cartesian components of f bar. Then dou f by dou t equal to dou f1 by dou t I bar plus dou f2 by dou t j bar plus dou f3 by dou t k bar. I comma j comma k fixed directions. And higher order partial derivative. How to find higher order partial derivative? Suppose f is the function p comma q comma t. We can dou by dou t of, this is dou by dou t of f, first order. Second order, dou square by dou t square of f bar. And also dou by dou p of dou f by f bar by dou t can be written as dou square f bar by dou p dou t, like this. Okay, now first derivative with respect to t, after derivative with respect to p, like this. So these are the higher order partial derivatives. Higher order partial derivatives. Okay, all of you. What is vector point function? What is scalar point function? Here we discuss here. First, vector point function. In three-dimensional space, let point p x comma y comma z, we associate a unique vector f bar x bar comma y comma z x y z. F bar is called a vector point function denoted by f bar of x comma y comma z equal to f1 I bar plus f2 j bar plus f3 k bar. This is the vector point function. And what is scalar point function? In three-dimensional space, to each point x, y, z, associated unique real numbers called scalar function, say pi. It is denoted by pi. Thus, pi of x comma y comma z is called a scalar point function. We define vector point function and scalar point function. And vector point function have the components. These are the f1, f2, f3 components in Cartesian form. In case of scalar point function, there is no components. So, it is a scalar point function. Vector point function and scalar point function we define like this. Vector differential operator. Vector differential operator. It is very important in vector differentiation. What is vector differential operator? Vector differential operator is del. This is del. This is I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z. This is the vector differential operator. It is denoted by del. It is denoted by del. Okay. So here pi is the scalar function. So del pi is gradient, grade of pi. So del pi equal to what? I dou by dou x I bar plus j bar dou by dou y plus k bar dou by dou z of pi can be written as I dou pi by dou x plus j dou pi by dou y plus k dou pi by dou z. Here this is the scalar point function convert into vector function by using del pi. This is denoted by grade pi. Similarly, divergence pi. What is divergence of f bar? If f bar is vector point function. Vector point function. Okay, then div f bar equal to del dot f bar I dou pi by dou x plus j dou pi by dou y plus k bar dou by dou z dot product f bar f1i plus f2j plus f3k bar. Okay, then here this is I dot I is equal to 1 dou f1 by dou x. J dot j is equal to 1 dou f2 by dou y plus k dot k is equal to 1 dou f3 by dou z. Means div f bar is the point function. Then you want to find div f bar, then you will get the scalar. Okay, if pi is the scalar point function, then you will get the vector function by finding grade pi. Okay, next curl f bar. What is curl f bar? Del cross f bar. Okay, here this is I dou by dou x plus j bar dou by dou y plus k bar dou by dou z. Cross product f1 I bar plus f2j bar plus f3k bar. How to find this one? Here this is I bar, j bar, k bar. Data of this is dou by dou x, dou by dou y, dou by dou z. f1, f2, f3. Like this. This is finding the determinant. Then you will get the curl f bar. Okay, here del is the differential operator, vector differential operator. That is del I dou by dou x plus j dou by dou y plus k bar dou by dou z. If pi is the scalar function, then we find grade pi. Grade pi is the vector function. You will get the vector function. Convert into scalar into vector function. And in case of div f bar, del dot f bar, this is the dot product, you will get the scalar function. In case of curl f bar, del cross f bar, you will get the vector function. Okay, so this is the, by using the differential operator, you can find the gradient of the scalar function, divergence of the vector function, and curl of the vector function. These are the three operations in differential, in the vector differentiation. In vector differentiation, this is very important.